Hi Math 2 students, and welcome to your 5.3 Ed Puzzle. So we got our couple of definitions here. Bisect, that means when a point, segment, or ray or line divides a segment into two congruent segments. All right, so really what that means is that you have a line, and there's either another line, a point, something like that cuts it in half. And of course, when it cuts it in half, it's going to make two congruent pieces. The midpoint is a point that divides a segment into two congruent segments. So if we look at the picture I just drew, this would be the midpoint. So the midpoint bisects. All right. So for example 1, it says if XY, so that's this guy, bisects AC, what conclusion can we draw? So what that's telling you is that XY cuts AC in half. So if it cuts AC in half, we could say that it forms two congruent line segments. So we could say that AB is congruent to BC. All right, we cannot say that XB is congruent to XY because we don't know if it's bisected. But we do know that AC is bisected. So we could say AB is congruent to BC. All right. Then it says if D is the midpoint of FE, what can we conclude? Well, if D is the midpoint, that means that it's going to cut it in half. It's going to bisect it. So we could say that FD is congruent to DE. All right, next. It says given that OM is x plus 8, MP is 2x minus 6, and OP is 44. What is the midpoint of OP? All right, so let's go ahead and write this out here. We have O. Here's the thing, too. You kind of have to look at the information given so that you can draw a picture. This is kind of confusing. It's like, well, you know, where does the P go? Where does the M go? What's going on? So what we're going to do here is they're asking, is M the midpoint of OP? So what that means is we're going to have a line segment, OP. All right. And let's put M here. All right. We know it's going to be in the middle. We don't quite know if it is the midpoint. I should say we know it's in between. We don't know if it's the midpoint. Then they tell us that OM is x plus 8. And they tell us that MP is 2x minus 6. And then they tell us that OP is 44. All right, so what we can do is we just need to figure out, well, is OM equal to MP? All right, so what we can do is we'll say, well, x plus 8 plus 2x minus 6 has to equal 44. We know that, all right, because this plus this needs to equal this. You can see that that's true. So we write it like blue plus green has to equal the entire thing, which is 44. So you can go ahead and solve. We get 3x plus 2 equals 44. Minus 2 minus 2. We get 3x equals 42. We're going to divide by 3. And we get that x is equal, let's see, 40. Oh, I'm sorry, we're going to divide by 3. So we do 42 divided by 3, and we get x equals 14. All right. So now we can go ahead and, let's see. Whoa, what is going on? There we go. So now we know that x is 14, so we got to see if these two line segments are equal to each other. So the blue guy, we can figure out what OM is by plugging in 14. So we're going to do 14 plus 8, which is going to give us 22. Then we're going to plug into the green guy, which is going to be 2 times 14 plus 8, which is going to be 20. Oh, my goodness, minus 6. What the heck am I doing? 2 times 14 minus 6. All right, so we get 28 minus 6, which is going to give us 22. So since these are both equal, that means that M does cut that line segment in half. So you would say, yes, M is the midpoint of OP. All right, next one. Oh, they, I didn't realize they had a picture drawn for us. Oh my God, well, oh well. Sorry for making you draw that. All right, we got the median. So the median is a line segment drawn from any vertex of a triangle to the midpoint of the opposite side. So what does this mean? Okay. So first off, of the vertex, the vertices of the triangle are going to be, the 3 points of it. All right. And it says a median is going to be drawn from a vertex to the opposite side. And then it's going to cut that side in half because it's the midpoint. All right. So for example, let's say I wanted to draw in, here, I'll draw another triangle here. And we'll label it A, B, C. Let's say I wanted to draw a a median that started at A. I would draw it from here to here. And that would mean that it would cut this line into 2 perfect equal segments. All right, so that's what that means. All right, so now they tell us that TW is the median. Then they tell us that ST is x plus 40. And one thing you guys really got to do is draw on these pictures. Or if you're able to draw on them, draw on them. Then we get that SW is 2x plus 30. And we get that WV is 5x minus 6. All right. So they told us that TW is the median. So if TW is a median, that means that this line segment has to be congruent to that line segment. And if that's the case, we can set them equal to each other. Okay, we can set 2x plus 30 equal to 5x minus 6. I want to point out, we don't know the relationship of ST to SW or WV. We can't use that at all right now. We're ignoring it. The only piece of information we have is that this guy is congruent to this guy. And the reason we have that piece of information is because they told us that TW is the median. So we're going to go ahead, we're going to say 2x plus 30 is equal to 5x minus 6. So we can go ahead and solve that. We're going to do minus 2x. We get 3x minus 6 equals 30. Add 6. We get 36 equals 3x. Divided by 3, we get x equals 12. All right? But we're not done. We actually haven't answered any of these questions yet. All we did was figure out what x is. So now what we can do is go plug in x to these different expressions. All right? So to figure out what SW is, we're going to plug in 12. So we're going to do 2 times 12 plus 30. We get 24 plus 30, which is going to give us 54. Oops. So we could say that SW is equal to 54. All right. Now, we could go ahead and plug into WV, but we already know that SW is congruent to WV. So guess what? We don't even have to do that. We know that WV is going to equal 54 as well. You could plug it in to double check, but we won't even bother. Then we got to find ST. So we're just going to plug in 12 here. And we get that ST is 52. So again, you really have to double check yourself on all these. Make sure you're actually answering the question that is asked. All right, let's try this next one. We have the term perpendicular. So lines, rays, or segments that intersect at right angles. So if it's said to be perpendicular, what the heck? You know automatically that you are going to get, here, let's see, let's make this a little bit thicker here. Whoa. We don't need that. There we go. That's a little bit better. You're going to get a right angle, all right, when you have perpendicular, or a 90-degree angle. So it says, are we able to assume that lines, rays, or segment are perpendicular? So if we look at something and we're like, oh, that looks like a right angle. No, you cannot. All right. You cannot assume that something is perpendicular. It either needs to have, you know, the little 90-degree mark, then you know it's perpendicular. But you can't just look at something. Like if I was given no information on this, I couldn't just go say, oh, that looks like a right angle. I'm going to, you know, put a right angle mark in there. Well, I don't know. Maybe it's 89 degrees, right? It might be close to 90 degrees, but may not quite be 90 degrees. So you need to either be flat out told, or you have to be able to draw that conclusion from the information given. All right. So here for example 5, it says if EH, and this is actually a new symbol that we're learning here. This is the perpendicular symbol. All right. So it says if EH is perpendicular to HG. So they're telling us EH is perpendicular to HG. So what does that mean? That means that this angle here is going to be a right angle. All right. So it says, then which angles can you conclude are right angles? So really, I guess I just kind of gave you the answer here, right? If they told us that these two are perpendicular, we can conclude that angle EHG is a right angle. All right. We cannot conclude that this is a right angle. We cannot conclude that this is a right angle because we don't have any information on that. But we can say that this is a right angle since we know that these two sides are perpendicular. All right, for example 6, it says, given that KJ is perpendicular to KM. So let's draw that in. We have KJ and KM. All right. They said this is perpendicular, so we can draw in a little box there. It says JKO is 4 times as large as MKO. So it says find JKO. All right, so this is a tricky one. But what they're telling us is that JKO is 4 times as large as MKO. All right, so let's just say MKO is X. If JKO is 4 times as large, we can say that it's going to be equal to 4 times X, right? If this is 1, that's going to be 4. If this is 2, that's going to be 8, right? If this is 10, that's going to be 40. But we got to, so we can use these variables to kind of describe what they told us here. So now it says find the measure of JKO. All right, so what the heck are we going to do here? Well, if we look, we know that this big guy here is going to be equal to 90. And we know that because we figured out these are perpendicular, which means that it makes a 90-degree angle. So what we can do is add up these two angles that make up this 90-degree angle and set it equal to 90. So we'll just say 4x plus x equals 90. You get 5x equals 90. Divided by 5, and 90 divided by 5 gives us 18. All right, so again, x equals 18, but they're asking for JKO, so we need this big guy. So we're going to do 4 times 18, which is going to give us 72. So we'll say the measure of angle JKO is 72 degrees. All right, so let's go ahead and continue on. So the next portion here talks about altitude. So that is a line segment drawn from any vertex of a triangle such that it is perpendicular to the opposite side or an extension thereof. All right, so basically, first off, let's talk about what perpendicular means. Oops. Perpendicular means that it forms a right angle. All right, so if we look here, if we wanted to draw an altitude for this triangle, this would be an altitude, all right? And we could also, you should be able to draw multiple altitudes. And of course, these aren't perfect because I'm not using a protractor, but it gives you a pretty good sense of, you know, what an altitude is gonna look like, all right? You should be able to draw 3 of them for a triangle. Let's see, something like that. All right, and what it does is it forms a right angle. All right, so here This actually, the leg is the altitude because it forms a right angle there. And this leg also is an altitude, right, because it forms a right angle. And we can draw one more in. That looks about right angle-ish. The altitude would look something like that. And then this last one, if you wanted to draw an altitude for this guy, you'd actually have to do like a little bit of an extension. It would look something like that. All right. And then you could also draw an altitude from here to here. Oh, also, I should have drawn in the little box. All right. So essentially, again, an altitude is a line segment drawn from any vertex of a triangle such that it is perpendicular to the opposite side or an extension thereof. This is that extension they're talking about. All right. So now we got perpendicular bisector. So this is a line, right, or a segment that bisects and is perpendicular to a segment. So we've talked about bisectors before, all right? And that means that, if I were to say, like, this pink line bisects the green line, all right, what that would mean is that these two sides of the green line would be congruent. However, we haven't talked about it being perpendicular. So a perpendicular bisector is both. It is perpendicular and it bisects. So here it says that AE, so that's this guy here, bisects, is a perpendicular bisector of BD. All right. So this implies a lot of things. This implies that that is a right angle. And then since it bisects BD, it implies that BC is congruent to CD. All right. Now, one thing we cannot conclude. All right. And maybe I'll underline that. We don't know that AC is congruent to CE. Okay. Because they didn't tell us that BD is a perpendicular bisector. So since AE is a perpendicular bisector, we know that it bisects this, but we can't say that the opposite is true. All right. Let's go ahead. Next, we got if a point is on the perpendicular bisector of a segment, then it is equidistant to the endpoints of a segment. All right. So basically what that means is that if we were to put a point on this perpendicular bisector, all right, it is going to be equidistant to the endpoints of this segment. Okay, so we could draw a dot anywhere on AE, and it's going to be equidistant from the endpoints of BD. Then we got angle bisector. So if a ray divides an angle into two congruent angles, then the ray bisects the angle. All right. So it says, given that KO bisects JKM. So what this is telling us is that this line is cutting this red angle in half. And they also tell us that JKM is 58 degrees. So this entire thing is 58 degrees. All right. They want to know what OKM is. So we're looking for OKM. Well, if OK or KO splits JKM in half, we can safely assume that OKM is going to be half of 58. All right, so you would just do 58 divided by 2. And you're going to get 29 degrees. So we'd say the measure of OKM is 29 degrees. It's half of that. All right, next it says, given that the measure of angle RIA, or AI, oh my goodness, sorry. So RAI is 3x minus 5. And that IAN is x plus 27. So IAN is x plus 27. And that AI bisects RAN. So it's saying that this cuts angle RAN in half. All right, they want us to find RAI. So basically, since we know that this entire angle gets split into half exactly, since it's bisected, we know that angle RAI is going to be congruent to angle IAN, since AI bisects that big angle. So what we can do then is set these two expressions equal to each other. All right, so we'll say 3x minus 5 equals x plus 27. So we'll do minus x, we get 2x minus 5 equals 27, plus 5, we get 32 equals 2x. We get x equals 16. But of course we're not done. We figured out what x is, but what did the problem ask us to do? It asked us to find the measure of RAI. So what we're going to need to do is we're going to need to go and plug 16 in for x. All right, we go to RAI. RAI is equal to 3x minus 5. So we'll go ahead, we'll do 3 times 16 minus 5. All right, so 3 times 16 minus 5 gives us 43 degrees. All right, so the measure of RAI is going to be 43 degrees. All right. Next, for example 9, it says EH is divided by GF in the ratio 5:3:2 from left to right. If EH is 30 and find FG and name the midpoint of EH. Oh boy, lots going on here. Holy smokes, but that's okay. So basically they tell us we got a line that's called EH. So let's go ahead and draw that. And then it says it's divided by F and G, all right, in the ratio 5:3:2. So we'll say F and G, all right, and then the ratios are 5, 3, and 2. So when you're doing a ratio, what you can do is you could say 5x, 3x, and 2x. All right, we don't know what x is, but we know that the ratio is 5:3:2, so we can put that down. So this is how you construct an image like this. Then it says if EH equals 30, find FG and name the midpoint. All right. So we know that the entire thing is equal to 30. All right. So they want us to find FG. Well, let's go ahead. Here, actually, I can go like this. We know that this is equal to 30. So what we can do is we can add everything up and set it equal to 30. So we're going to say 5x plus 3. X plus 2x is going to give us 30, which when we add up the like terms, we get 10x. Divide by 10, we get that x equals 3. So if we're trying to find FG, we're just going to plug in 3 for x. So FG is going to be 3 times 3. So we'll just say FG is going to be equal to 9. All right, so let's go ahead and find what all of these are equal to. We know that FG is going to be 9. EF, which is this guy here, is going to be 5 times 3, which is going to be 15. And then GH over here is going to be 2 times 3, which is 6. All right, so we see that EF is 15, and we're trying to find the midpoint. Well, we can see here 9 plus 6 is going to give us 15 over here. So you could see that F is actually going to be the midpoint. And the reason F is the midpoint is because it splits it in half here, right? We got 15 and then 15. All right. Second to last one. You guys are doing good. So it says C is the midpoint of AB. Find AC, CB, and AB. Holy smokes. All right. So first, important piece of information. C is the midpoint here. So if C is the midpoint, that means that it splits AB into 2 congruent parts. So we know that AC is going to be congruent to CB. So since we know that, we can set these equal to each other. So we'll say 2x plus 1 equals 3x minus 4. We'll do minus 2x add the 4 over, and we end up with x equals 5. Okay, unfortunately, that doesn't answer any of the questions. We got to find AC, CB, and AB. So first, let's see. Let's find AC. All right. So we know that AC is equal to 2x plus 1. So we're going to plug the 5 in. We're going to get 11. So we found out that AC is 11. Now, for CB, we should be able to just know what it is, right? We have that AC is congruent to CB. So CB better be 11. But let's check. Let's make sure we did it right. So we'll plug in the 5. We're going to do 3 times 5 minus 4 gives us 15 minus 4, which is 11. Phew, great. We got it right. Then they want us to find AB. So AB is this entire thing. Well, AB is going to be AC plus CB. So you would just add those up. And you get that AB is 22. Awesome job. Now we've got number 11. So it says LK is the perpendicular bisector of TN. The intersection of LK and TN is F. TF equals 3. What is TN? What is the measure of LFN? Draw a picture to solve. All right. So let's see. Let's draw this out. So it says that LK is the perpendicular bisector of TN. And notice these different notations, okay? Since TN doesn't have the arrows, that means that it is a line segment. So it would be drawn like that. So we'll draw in TN. And then they say that LK is the perpendicular bisector. So let's draw LK in. LK's got the arrows. And since LK is the perpendicular bisector, we know that these two sides of this segment are going to be congruent. And they also tell us that the intersection of LK and TN is F. So we could go and put in a little F here. So they tell us that TF is 3. So this distance here is going to be equal to 3. They want to know what TN is. All right. Oh, and also they told us perpendicular bisector, so I should throw in the right angle there. So if we look to find TN, we need TF and we need FN. Well, FN is congruent to TF, which is 3. So we know that FN is 3. So then TN, which is the whole thing, is going to be 3 plus 3. So TN is going to be 6. And then they ask, what is the measure of LFN? So they're asking us, let me erase some of this craziness I got going on here. The next thing they ask is, what is the measure of LFN? So LFN. So basically, LFN, that's part of this perpendicular area. All of these angles here are 90, all of them. So it's 90 plus 90 plus 90 plus 90, which gives you the 360 around. So the measure of LFN is going to be, or actually I should have an angle in there, right? Measure of angle LFN is going to be 90 degrees.